Hello and welcome to our webinar, How to Tame Your Screening Data, presented by Guillaume Payard, Science Cloud Advisory Solution Scientist, Lead Customer Project Management at Dassault Systèmes BIOVIA. My name is Michael Gans, Senior Program Manager at Dassault Systèmes, and I will be moderating this session. Before we begin, I'd like to note that attendee phone lines are muted. If you have any questions during the webinar, please submit them at any time via the questions or chat windows in the GoToWebinar control panel, and we will answer them at the end of the session. And now I'd like to turn the webinar over to Guillaume to begin today's presentation. Guillaume, it's all yours.
Thanks a lot, Michael. Hi, everyone. Thanks for joining this webinar. Today will be about how to tame your screening data, and so more specifically focusing on two great solutions from Dassault Systèmes, BIOVIA Assay and BIOVIA Sample for Assay. Before we begin, let's just have a look at what is about handling screening data. Well, there's probably mainly two aspects. I mean, we can categorize the functionality you need to address this problem as a whole. One is about storing information that stores about, well, first the entities you want to screen. This is typically a registration system that will perform uniqueness check, provide an ID. From there, you will create containers for those entities. So you need to track your physical inventory. Again, have some IDs about the ID from providers. And at the end of the screenings, you will have generated some assay results. The assay needs to be clearly defined so that you can understand and reuse those results. You need that result repository in place, some IDs that are assigned to those results. But to produce all that set of information, it's also about accessing some data, some content that is provided by some of the systems. And creating a notebook, of course, will document the provenance of the entities and how these assay results have been produced. You will need to handle some information about your stocks that kind of relate to the containers aspect. Then you will have to process the result of your assay. So instruments will just produce your data that will need to be processed, analyzed to produce the final assay results. And overall, as across all of this, there is a concept of project overview about what's happening, why those results have been produced. What is the scientific decision you can make from them? So while Dassault Systèmes is and BIOVIA more specifically is providing solutions to address all those aspects, today we will focus on 4 parts around on the logistic aspect about stock management and container, but even more extensively around assay processing and how to produce those assay results that will drive your scientific decision process. And to address those, we will focus on 2 solutions, BIOVIA Assay and BIOVIA Sample for Assay, which just actually wants you to able to process results and to handle and manage them for any kind of assays. So we start with kind of defining what are those solutions, then understand how they work, going through some demonstration and some key aspects. So to start with, what is BIOVIA Assay? Well, first of all, that's a web application. So that means it's easy to deploy to all your users, all the members of your screening teams, and with a very low footprint. But it's also a web application available in the cloud or on premises. Basically, the same applications with 2 different types of deployments. It's of interest depending on the strategy of your organization, of course, regarding management of software and everything. But it also brings some interesting aspects. If you take an act on the overall externalization of resources, having your solution in the cloud allow you to make that same solutions available to people outside of your organizations, which provides some even more flexibilities. A web application available in the cloud or on premises to process any type of plate-based assays. Here on the screen are just a few examples from the very classical primer screening or those response. Kinetics assay, eye contact screening, ELISA, and so on. This is just a few examples for which assay will provide some ready-to-go solution out of the box. But the system is thought in a way that you can extend assay to new type of assay, but also customize those existing assays to your specific needs. Taking eye contact screening, for example, sometimes your instruments will also come up with some imaging processing tool that already produce some numerical data that can be treated directly in assay. Some of the time you will have need to put in place the extraction process of those numerical data from your images. And all those different choices, also taking the variety of instruments you have to handle that will, along those assays. BIOVIA assay is providing that flexibility to address all those kind of assay. Web application on the cloud, any type of assay, and it is BIOVIA assay is really focusing on taking you from your raw data to the final result of interest, up to the publication process and warehousing of those results for future consumption in the rest of the organization. And the final aspect, which is the key principle in BIOVIA assay, is that it provides a common workflow to guide the users through the process of going from raw data to end results. And we'll see more about that process in a few minutes. Now, BIOVIA assay to handle that common workflow, it also provides advanced visualization and analytics. Those are provided out of the box, but it's also strongly integrated with some other solutions, such as TIBCO Spotfire for the visualizations and BIOVIA Python Pilot for both computation, analytics, and visualizations. And you can use both of those solutions to extend the capabilities of BIOVIA assay. Now moving to BIOVIA Sample for Assay. Again, it's a web application. It's really the sister application for assay in charge of handling the tracking and inventory of vials, plates, and racks. So web application again in the cloud or on premises for extended flexibility of deployment. The other common principle that Sample for Assay is sharing with Assay is to provide a guiding workflow for it to easily prepare and execute operations around containers. So again, the users is driven through the different steps of that process, from item requesting, task requesting, sources processing, and storage. And again, we'll see in more details what this is about in just a minute. And finally, because it's even important, it's quite a key point for such a systems. So obviously, it's natively integrated with BIOVIA assay and goes end-to-end with the screening solutions, but it can also be seamlessly integrated with your other solutions through comprehensive API. So, for example, typical integrations will be on the informatic end will be with registration systems or inventory systems. And on the hardware side, that would be about integrating with, for example, the liquid handlers to be able to provide instructions from liquid handlers and receive information from those liquid handlers. So the key concept here, as I said, is that both applications provide a common workflow to all users. So it's really about enabling the collaborations between the different members, different type of users involved in screening activities. That starts with the assay designer that will, of course, is in charge of physically designing the assays and the condition of those assays, but will also be in charge of designing how to analyze the results coming out from those assays. So the role of the assay designer in the context of assay in particular will be to design a run template so that every following run executed by other member of the team, typically the assay screeners, will be made in the same conditions so that the analysis can be comparable. Sample managers are also involved through the use of BIOVIA sample and assay. And finally, there is that role we call assay publisher. So that can be sometimes just someone validating the results produced after the screenings, or simply in charge of putting the data in the right places, but which is a key members of this virtuous circle of collaborations to make sure that the results are available to the wider scientific community to drive their decisions. So it's really about providing a common tool that all those type of users will be able to to easily access and benefit from. So there's a few, I try to categorize the key value we're trying to bring with BIOVIA assay and BIOVIA sample for assay in three categories: simplicity, data integrity, and openness. This is what we will look at right now. So let's start with simplicity, reducing best recipes through guided workflows. So yeah, I take that picture of an omelette, which is probably the simplest, one of the simplest dishes you can think about, but nevertheless, you need to know the right recipes if you want to make a really good one. So let's see how BIOVIA assay and BIOVIA sample for assay help you to share those good recipes. In both cases, and as I said already, both applications are workflow-based applications. And for each application, the workflow are built on a common skeleton. In the case of assay, of BIOVIA assay, that workflow is about taking raw data, taking them through all necessary steps, and getting the final results. For sample, it's about gathering all the informations, all the different kind of transformations you want to handle around your samples, your containers, and so on. Turn that into jobs that will be executed by someone. So let's start with the BIOVIA assay workflow. It all starts with being able to read and understand the data, the raw data, which typically are files produced by instruments in many various formats. So you need to be able here to accommodate all those different formats. And so there is a need here for some flexibility for advanced users to define the readers that will be able to understand that a specific type of data, and for the end users to pick that reader. Once the data has been understood from the raw data, you can just move to the logical next step, which is to describe the plate you have just been using. So just defining plate layout. And again, you will be able to define different layouts based on the type of experiments you're running. When the plate is mapped, even before running into any further analysis, there is a necessary step of normalization of the data and to be able to perform QC, to be able eventually to invalidate wells or plates, depending on what happened during the run, to be able then to iterate on those invalidations, perform validation again, check that everything is right, so to be able to move to the next one. At that stage, the two critical things you want to be able to tune to your specific needs is, on one end, the normalizations you're applying to the data, and the other end, the visualization that help the end users to perform that QC step. Once you're happy with the quality of your data, you can move to the next step, which is about performing sample analysis, which basically is about, well, defining the sample mapping of your plate, define exactly what was in the different well, different type of if there was replicates, what were the conditions in terms of obviously concentration, but also any other kind of conditions you may consider in your assay, and then select specific analytical methods, specific visualizations to be able to produce the final results, and finally publish them to a repository typically. And again, it's about being able to integrate with those different repositories. Sometimes it's also about being able to capture the process in itself, and you can also provide, along with the data, publish, for example, to a notebook or some other process capture system, push that information as well during the publishing step. Now let's talk about BIOVIA sample for assay workflow. It's a way to look at it is to start with the item. Typically you start by requesting some items. This is the objects, the entities that you want to work with. The next step is about requesting a task on those items. That could be from starting from a mother plate or different mother plates, do some cherry picking, stuff like this. So defining what you want to do with those items. Next one is about sourcing, making sure you have enough materials to actually perform those tasks. And process them. So that's basically instructing the liquid handlers typically to perform those operations necessary to get the expected result, and finally handle the storage of those potentially new containers you just created. So sample for assay is really about defining those the parameters and the configuration of those different workflows. Here are just a quick screenshot of the UI itself. That is a front page you see when you connect to sample, with the different typical tasks, which come from the simplest one, which are registrations, which is quite often actually handled directly by connections between some initial system when it comes to register batches, can be plugged into some other system that will push the information into sample. Reception to when you're receiving plates, vials, and so on. Transformations, so starting from existing items to create new ones, etc. The deployment of the search and deployment options is also about providing that simplicity. Of course, you can go for on-premises. You get your own server. You can have direct integration with your in-house databases. I mentioned registration, for example, on one end, but also result repository when it comes to publishing assay results. But cloud is, of course, providing a lot of security. You don't have to worry on hardware or updates of the software anymore. Secure solutions, very easy to share with external partners if you want to be able to provide them with the right solutions for them to process the raw data they're producing themselves, make sure they're processing them in the same way you would like them to process them, share some more advanced information about your screening data. So overall, BIOVIA assay and BIOVIA sample for assay, by providing those common workflow, make sure that the user are easily guided through their different tasks and really can focus on science, and the dual deployments, either on-prem or in the cloud, make the solution very easy to deploy, very easy to maintain, especially when made on Science Cloud as a cloud solution. Having talked about simplicity, now let's talk about data integrity. And what I mean really by data integrity is making sure that the data you're producing are produced in the right way and recorded in the right way. So it's more about standardizing and automating the processing of your data, either from a logistics standpoint or from an assay standpoint, an assay execution standpoint, and making, building the trust on the data produced by your screening activities. So let's have a look to the application in action to do that. And starting with a fairly common example, say that as a screener, I just want to process a primary screening run that I just performed on a new set of compounds. So let's have a look at a quick video where I'm just performing the operations. Sorry. So it all starts with selecting a mode, because the same application will allow you to either design a new run, design a template, or execute it. And here, execution and autopilot are two dual modes. I'm picking here autopilot. That will allow me to simply provide the raw data. So here I have selected a template. As you can see here, provide a name. I could assign a campaign. Eventually ask for email notification where the processing will be done. And the only thing I have to do really is pick up the raw data file, then select. I don't have to provide any well information here. It's a fairly simple screening. The sample mapping will come directly from the sample application itself, so I don't have any more information to provide. And from there, I can just launch the run. Very quick, very easy. And here the process will go automatically through each individual steps. So setting up the layout of the plate during the well mapping. Here now we are applying some normalization, predefined normalization on all plates. Here we have 9 plates in that particular assay. Once this is done, the sample mapping is automatically made. The aggregation step. Here there is not that much aggregation, it's just a primary screening. Applying some more statistics. And finally, when this will be done in just a few seconds, we'll be generating a final report that will bring back to the user all necessary information. Because, well, obviously this demonstration could look like, well, it's a bit of a black box, but it's absolutely not that, and that's what we will see in a second. So first of all, once the run is performed, you get access to a summary report that will also bring you some information. So here I'm just downloading that report, and you can see here some key informations. You see that some well have been automatically invalidated, as well as some hit that has been selected. This is because the designer of the run, the designer of the template, has been selecting some automated analytics that have performed that selection for me. But nevertheless, I always have access to all information. And here I'm just going back to the complete analysis workflow. So here I'm kind of starting from the end. This is the final result. I can see the hit here, the hit that have been selected, the graphics, the visualization I have here are the one that has been defined by the run designer, and you can see also the automate selection tool that has been put in place. In the same way, if I go back now to the well validation step, which is basically the QC, again I can review all the details of the run. I can understand how the well invalidation principle has been made, and I can really see each step one by one. Here we're just reviewing the sample mapping, the selections of the analysis. Here I've just performed some basic statistics, and back to the initial sample analysis. If I get any issue with that run, I can unlock it if I'm allowed to, and I can just modify any settings along the way to, you know, tune the analysis to what I would have done as a human. But most of the time, the expectation is that you know, you can, at least for simple runs, and you can decide what you're automating or not in the process. But the idea is that you can almost, those very common runs can almost be run end to end without any problem. And actually, even the initial step, which was about picking the raw data file, could also be automated. You could imagine for some customers, what they're doing simply is that some process is picking the raw data file out just at the output of the instruments, pushing them through those autopilot analysis, and just reviewing really the end result, the report we've seen, and eventually going back to the result as necessary. So really, the execution mode is about, well, saving users time. The right options have been selected by the asset designer so that you can focus on the science, on taking decision, and you are sure that your analysis has been standardized and are coherent from one run to the other. So, as I said, the method that's used here is autopilot. If I had used what is called just simple executions, basically that meant that I would have to go step by manually through every single individual steps. But autopilot really allows you to perform an automated full analysis of your plate-based assay. So almost no human intervention, but still staying in control with the reporting and some alerting that you can put in place. Last week's seminar, the first of our series was fully dedicated to autopilot. So I encourage you to have a look to that webinar if you want more detail about that specific feature. Talking about automations, every single step of an assay run, of the processing of your data, can be automated through Python Pilot, which is, you know, technically speaking, it's in a great part how autopilot is handled. But another interesting thing here, it's also an easy way to just reprocess your legacy data, which could be in a case where you have strongly changed the way of analyzing a certain type of run. But even more interesting, it's a really great way to migrate legacy data into assay, and that's what we have been performing with several customers on different legacy systems, either BIOVIA legacy system or other legacy screening systems, which allow you to continue to have all your historical data with you in the same system, process with your latest standard for in terms of analytics. On the end, on the sample side, the standardization really comes at the level of sample tracking. There is a strong focus on keeping track of the containers relationship, on how those and the integration with the registration system. So again, here the idea is to guide the user as much as possible through the workflow, and that synchronization of containers and sample is made easy by the availability of APIs that allow for these integrations between sample and other systems. So that data integrity is really about, as I said before, standardizing the analysis, standardizing the assay definitions, automating as much as possible the process of assay data, including legacy data, again, letting you in control, and the tracking of all the information around the assay, in particular containers and samples. Let's move to the next part, because what I showed here is really just running through a predefined process, which is great when you're really in execution mode. But nevertheless, before that, you need to be able to handle those numerous type of assay that I mentioned before. And I would say in most cases in science, well, every case is specific. So you need a way to have an open system. BIOVIA assay is absolutely not a closed system. It's all about being able to define your own specific way of working with your data. So, and which is important in terms of being able to accommodate a large number of type of assays, which is also important to keep up with the science, with a new way of analyzing your data. And so what if you want to integrate your new statistical tools, new visualization, and so on. So let's go into a new part of the demonstrations, this time as an assay designer. So what I will show you now is typically the work that is necessary for someone to define that template I have been using just before in when running my primary screen in Autopilot. Here we will just have a look at a slightly different type of assay, which is a dose response assay. So let's start. The start is obviously pretty much the same. That's the same tool, just used by a different person. So this time we are in a design mode. So I'm just defining the name of my assay. The next step for me will be to explain to the system what is the format of my plate and what is the format of my data. So here I've just selected a user. Now I'm just providing the raw data themselves. And I will just, upload the file and then move to the next step, which is to attempt to apply the reader to the raw data that has been provided. Here everything works fine. I get 6 plates. I get 1 measurement in my plate. I can move to the next step, which is to define the plate mapping. So here I will pick a layout for my plate. Some layouts have been predefined. I could define more, but in that case, I will just pick those response layout, apply it to all my plates. So you can see now that the control layout has been defined for each of them. Eventually, I could individualize that setting, but that's not the case here. Now I can move to the next step, which is to define the QC. So I'm defining the tool I want to use to visually perform the QC. In that case, I will go for using TIBCO Spotfire to perform that analysis. Existing templates are available to me to choose from. Again, this is a list that can be enhanced. So now I'm picking some normalizations to apply to my data. So I will just go to apply some standard inhibition calculation to start with. Then I will go for some Z prime factor to be computed on my plate. And finally, I would go to the Z-score. Every time I have to explain to the system, which readout to be considered. So now going for the Z-score. Again, those method of those normalization, the list is an open list. We provide some out of the box, and that has been eventually enriched to your particular needs. including some, analytics of your own. So now I get all those informations. Here I will just, perform something pretty simple, selecting everything with a z-score with an absolute value greater than 2, invalidate the wheel so that we recompute the informations, show back to me the state of the QC. Eventually, if I wanted to, I could define an automated threshold to automatically invalidate the wells in the same way that I did here. So I could say, well, everything that is beyond 2, let's invalidate it by default, which I didn't do here. Now moving to the next stage, which is to prepare the sample analysis, first doing some sample mapping. So here I will provide, here I'm using a file. Again, I could pick that sample and those definitions from sample, for example, or from some of the systems. So I just provide the file, apply it. There is some mapping step. And now I will have the mapping has been performed. So here I can see I have one sample per row. And if I move to those, you will see the dilution that has been applied across the row as well. Now that the mapping is done, we can move to, we'll be able to move to the sample analysis. So we can see here the sample have been mapped and the dose have been mapped on every plate. Let's move, select the series we want to analyze. So the inhibition have been computed before. Selecting that value. And again, I will now define some additional value for analysis. So here I will simply compute the IC50s and the related parameters using one of the available methods. Again, that methods, the list of methods available is, there is some existing out of the box and you can add more depending on your needs. Having done that calculations, I can now actually perform the calculation, which is what is happening here. So waiting for a few seconds for that to happen. Now completed, and now I'm back to selecting my visualization. I decide now to use a pipeline pilot protocols to review my results. So pipeline pilot is grabbing all the information that has been previously produced and will generate a web interface for me to finalize the analysis. Again, I could set up here some automated selections for hits, but let's have a look first at the visualizations. By default, I'm looking here at all the curves for which the fit has failed. And for example, for this one, I can decide to act on it. So just open that particular IC50 curves, select some point that I consider to be, well, invalid. So mark them as such. Calculation is done again. Now I get a curve fitted here. I'm happy with that. This will just disappear from my list of unfit curves. Well, for the others, I decide that there's not much I can do. I'm okay with that. I can now lock my run so that it's now not possible anymore to modify the results. And I can move to the next stage, which would be, well, obviously to eventually publish that result to some repository, but more importantly for me here, to save that run as a template so that next time someone is performing the same run, the same type of assay, it will just be able to reuse exactly the same methodology than the one I used here in front of you. So the key principle of assay from that standpoint, going from design to execution, is that the same tool is used by both the designer and the screener executing a run after that. So to have a coherent definition of the data processing of your raw data. So as an assay designer, I configure every step of the analysis. I can test. I'm trying on real data. It can fit, from low throughput to high throughput analysis. No problem about that. But I know exactly how my analysis will be performed going further. I mentioned several times that there is many places where you will be able to extend the applications. And the preferred way to extend that application is through Pipeline Pilot. You will be able to use Pipeline Pilot to add new readers, add new normalizations, new new sample analysis, and also to integrate with new system to publish to. Python pilot can also be used on the visualization side, both at the normalization step and at the sample analysis step. Talking about validation, I also mentioned that you can use Tip Spotfire, in which case you'll be able to define your own template to be used during those steps. Another aspect that can be extended, you don't need Python pilot for that, is obviously the different plate layouts, for which we provide a nice UI for you to define your own layout, both for the mapping of the plate itself, so the control layout. That's also a way for you to predefine templates for conditions, for example, on your plates. All of this is great. We all already benefit a lot from the native integration between BIOVIA assay and BIOVIA sample for assay, but very obviously as well, there is a need for both those systems to be integrated with other systems. Hopefully BIOVIA systems, but of course third-party system as well. And this is only possible because we are providing APIs for both applications, which allow you to do different things, connections to registration, for example. So registrations, chemical registration, for example, to integrate with sample, or assay result registration system to record your final result. It also allows for integration with instruments, liquid handlers, for example, for sample, or picking the raw data coming out from instruments when for assay. And finally, it's also a good way to connect all that information to some business intelligence solution, such as BIOVIA Insight. So openness, again, it's about being able to configure the application the way you want, the way you need, extend the applications to your needs, and feed that in your ecosystem of software, in your research informatics installation. So hopefully you've seen now how BIOVIA assay and BIOVIA sample for assay are providing simplicity, data integrity, and openness to your screening data. That concludes my my talk here. Now it's open to your questions. As I mentioned during my talk, we had a first session last week, which was all about the automation aspect of assay, and in particular the autopilot feature. So feel free to register for the replay of that first session to get more information about that. Thank you.
Perfect. Thank you so much, Guillaume. Just as a reminder to the attendees of the webinar, feel free to submit any questions you have, and we'll be happy to answer them. We do have a little bit of time available here. Some of the questions that came in, I'll start off. The first one, I am using R statistics to perform some of my screening analysis. Can that be used in assay?
Yeah, well, the short answer is yes. In the case of R, there's actually a direct integration of assay, so you can use R natively without going through Python pilot. We are actually providing out of the box several normalizations and sample analysis methods that use R. And for to extend the questions to other statistical packages, where Python pilot would be a very convenient way to integrate those packages to perform the different kind of calculation, either normalization of the QC steps or sample analysis later on. So that's definitely possible, and it's actually a very common setup for our users.
Okay, great. The next question is, one of the assay types I'm using was not on the list you showed at the beginning of the presentation. Are there other assay types that you can process?
So the list I've shown before at the very start of the presentation is the one for which we're providing out of the box functionality. What I mean by that is out of the box normalization, visualization, sample analysis, and sample analysis visualization. But well, first of all, that list is evolving over time. We are adding more and more of those depending on our customer request, and it's quite a common way for us of working to for new type of assays, and that's actually how that happens for many of them to start working with customers and then productizing some of that with the agreement of the customer, of course, to extend that list. Now, in any case, as I said before, assay is very open to extension and customization. So as long as we're providing the level of complexity in the way we handle data that can fit with your new type of assay, I'm sure there will be there are ways to accommodate it. So to create yourself or to work with us to create new realization, new calculation to handle those type of assay. The data modeling itself is now fairly complex. It's, as I said, it handles HTS, kinetics, and some other complex assays. So there is, a lot of ways to. There is, So far we managed to extend pretty easy assay to any kind of assay. So yeah.
Very good. The next question we have, many of our screening activities are now externalized. How would that solution help in that context?
Okay, so I mentioned before that, well, several times actually, that BIOVIA assay is available on the cloud. And well, actually the first reason for us to put it on the cloud was not that much to accommodate the that trend in IT in general to look for cloud solution rather than on-prem solution. That was to address one of our initial customers, a large pharma working with a CRO organizations performing screening for them. And one of their complaints about that situation was that they didn't manage to get a complete overview on how the screening results produced by those CRO were processed, and therefore that led to kind of a trust issue between their internal users and the data coming from the outside. So the way for them to address that has been by opening their instance of assay in the cloud to those external users. There is a quite advanced level of security for you to clearly distinguish, what those external users will have access to. And what they were doing they were defining the analysis workflow of those assays so that they were sure that their external partner were analyzing their raw data the way they want, and also giving them an easy way to review those results, and therefore building the trust on the quality of the data. So again, it's coming back to that second point about data integrity. The fact that assay is available in the cloud allows you to promote that data integrity to your partners, and this is, to me, the key point for questions around externalizations and or collaborations around screening assay.
That's great. All right, it looks like that is all the questions that we have. Thank you again, Guillaume, for sharing your time and expertise today. I'm sure the audience found this information very useful and interesting. Thanks again for joining, everybody.
Thanks, everyone. Thanks, Michael.
Thank you. Until next time.